Hello and welcome back to our digital electronics series. Today, we're going to explore two essential components in digital systems, encoders and decoders. These devices play a crucial role in data conversion and communication within digital circuits. And as a special focus, we'll also discuss BCD to 7-segment decoders, which are commonly used in digital displays. Let's dive in. Let's start with encoders. An encoder is a combinational logic circuit that converts information from one format or code to another, typically from a high number of input lines to a lower number of output lines. In simple terms, an encoder takes multiple input signals and converts them into a binary code output. For instance, a 4-to-2 encoder takes 4 input signals and encodes them into 2 binary output signals. This is useful in systems where you need to minimize the number of wires or channels. On the flip side, a decoder does the opposite. It's a circuit that takes a binary code as input and decodes it to activate one of several output lines. Essentially, a decoder converts a binary code into a corresponding output signal, often used in memory address decoding or data multiplexing. For example, a 2-to-4 decoder takes a 2-bit binary input and decodes it to activate one of the 4 output lines. Let's break down how encoders work. In an encoder, each input is associated with a unique binary code. When a specific input is activated, the encoder outputs the corresponding binary code. For example, in a 4-to-2 encoder, if input line 3 is activated, the output will be 11 in binary. Now, let's see how decoders operate. A decoder takes a binary input and decodes it to activate the corresponding output. The output line that corresponds to the binary input code will be the only one active, while all others will remain inactive. For example, in a 2-to-4 decoder, if the input is 10 in binary, the third output line will be activated. Now, let's take a closer look at a specific type of decoder that's widely used in digital displays, the BCD to 7-segment decoder. BCD, or binary coded decimal, is a binary representation of decimal digits, and this decoder converts a BCD input into a signal that can drive a 7-segment display. In digital clocks, calculators, and other display systems, each decimal digit is represented by a 4-bit BCD code. The BCD to 7-segment decoder takes this BCD input and activates the appropriate segments on the display to show the corresponding decimal digit. For example, the BCD input 0011 corresponds to the digit 3 feet, and the decoder will activate the segments needed to display 3 on the 7-segment display. Encoders and decoders, including BCD to 7-segment decoders, have a wide range of applications in digital systems. Encoders are often used in keyboards, where each key press is encoded into a binary code that the computer can process. Decoders, on the other hand, are crucial in memory address decoding, display systems, and data multiplexing. In communication systems, encoders and decoders are used for data compression, encryption, and error detection. Understanding encoders and decoders, especially the BCD to 7-segment decoder, is essential for designing and troubleshooting digital systems. They play a key role in data conversion, display systems, and communication, making them indispensable in modern electronics. Thanks for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content. See you next time.